and some new information as well. Anyway, here goes. Let's take a look at the problem. All right. So what is it asking us?
Radior got statues of different sizes as a present from Codemaster for his birthday, each statue having a non-negative integer size. Since he likes to make things perfect, he wants to arrange them from smallest to largest so that each statue will be bigger than the previous one exactly by one. He may need some additional statues to be able to accomplish that. Help him figure out the minimum number of additional statues needed.
Okay, great. Now, before we go any further, just in case you're looking at this thing, Radiorg, who is this guy? Well, it's actually someone from the codefights app. He's this guy right here, the code bot. That's Radiorg. So, picture this guy arranging these statues. So let's look at the example here. I mean, we've got 6, 2, 3, 8. We'll look at it visually. So 6, 2, 3, 8. That's our array. That's our first example anyway. And the idea is that each of these represents the height of one of these statues. So we've got a 6, we've got a 2, we've got a 3, and an 8. And we want to sort of order them. We want to put them in order. So basically, or at least Radiorg wants to do that. Anyway, the point is, so we've got one with height 2. We've got one with height 3. We don't have 4. We don't have 5. We do have one with height 6. There's that one. There's no 7. We do have 8. So we'll get that in there. Okay, great. So I put these in order 2, 3, 6, and 8. And now if you think about what the question's asking, it's asking us, well, how many do we not have? How many would we have to add in here to what we already have? So we'll need 4, we'll need 5, and we'll need 7. Okay, 4, 5, and 7. There we go. Okay, so basically in this case, if we want to answer the question, it's specifically saying how many would he need to add. So in this case, it's 4, 5, and 7, like we just saw over here. But the thing is, the actual answer is just the 3. It's the number of them. So since there are 3 of them, we're going to return 3. Okay, great. So we can get started on this. Basically, the way we want to write our algorithm is kind of like what we did over here. So we start at the smallest element, which was the 2. And we're going to iterate. Maybe we'll do a loop for that. And we're going to go all the way up to the maximum element. And then in between, we'll just check, is this in the array? It is? Okay, great. Is this in the array? Yeah, it is. Okay, great. Is this in the array? No, it isn't. So then we'll add 1 to whatever variable that we're using to count the number that we need to add. So that's basically the way it's going to go. If it finds it, it'll do nothing. If it doesn't find it, then it'll iterate the counter. That's basically it. So let's go back to our window over here. Maybe we'll just sort of comment out a game plan over here. That's usually a good strategy. So first we want to identify the max and min elements. We want to find the biggest and the smallest in the array. Okay, and then after that we want to loop from min to max. So we'll probably do a for loop for that. And then within our loop, we want to check if the element is in the array, statues specifically. And if not, increment, let's call it count, I guess. And let's just instantiate count over here. So we've got var count. It's going to start as 0, and it's ultimately the thing that we're looking for. So we'll just sort of build this out now. So we're starting with a count of 0. This is how many are missing. So, again, we could call it something different. We could call it missing statues, how many statues are missing. Like, we could give it whatever name we want, but count is, I think, fairly self-explanatory here. So, okay, let's do this one step at a time. Well, let me just space these out first. Okay, great. So we want to do these one step at a time. the first thing we want to do is identify the max and min elements. Well, we've looked at a variety of ways that we can do this. So finding the minimum element in an array, finding the maximum element in an array. We could do, for example, we'll start with the min. So we could do something like statues dot reduce. You remember reduce is a function that'll go through an array. It's going to take two inputs, A and B, and we could basically just say something like, you know, if A is less than B, return A. And then on the next, whoops, that was just supposed to be A. Next line we could say something like else return B. Actually, if I'm going to do it that way, I need something like this. There, that's better. Okay, so we could do something like that, and that'll do it. You know, that'll basically give us A if it's the smaller one, or B if it's the smaller one. And it's going to run through the whole array, so this should give us our minimum. Let's just check, I guess. We'll say return min, and we'll see if that works. Yep, min is 2 in this case, 0 in this case. Should be 4 over here. Great, so that's working, but it could be a little nicer. So first of all, I'm just going to make it kind of a one-line thing, so we won't need this, and we'll just make it a ternary operator. So we looked at these last time. It's kind of like an if-else, but a lot more space efficient. So is A less than B? If yes, return A. If no, return B. So that should do the exact same thing. We'll put it to the test. Great, we're still getting the minimum there. But we already have syntax for that in the math library. We could say math.min A, B. And it's just going to take the minimum of either of those. And again, it'll run through all the elements, so we will get the minimum out of the array. But if we're going to use math.min, we might as well couple that with a spread operator like we saw last time. So we can say math.min ... statues and do this sort of thing. Okay, there we go. So keep in mind, it won't work without the spread operator if we don't have that. Well, it definitely won't work like that. But if we just do it like this, then it's basically just taking one input, which is an array. It doesn't understand what to do with that, so it's returning null. So we're not talking about the array itself. We're talking about the elements in the array. Oh, whoops. Okay, well, wait a sec. But anyway, the point is, so this spreads out. You know, it's the difference between doing this, like taking 6, 2, 3, and 8 as our inputs here, as our arguments, versus taking this one array and putting that in as the argument. So just to be sure that this still works, let's run the tests, and great, we find that it still works. So we could do var min is that, var max is math.max ... statues, and I guess I'll just return max just to make sure that that's working. Okay, 8 is the maximum there. That looks good. 3 is the maximum there. Okay, I think I'm convinced. So it's getting the min, it's getting the max. We have a reliable way to do that. And this will work for now. So maybe we'll clean that up more later, but for now we're just going to go with that. Okay, and then we want to loop from the minimum to the maximum. So by now we've seen a few examples of for loops. We've looked at a few different ways of structuring them. We're going to go with something fairly traditional for this one. I'm going to say n is going to be my variable that's going to start at min. It's going to iterate up to and including max, and we're going to do an n++. It's going to go up by 1 each time. And so then what is n? Well, n is basically this number here. This is n, this is n, this is n, this is n. So it's going to be whatever number we have, you know, whether we have a statue of that height or not. So then what we need to do here is this. We need to check if that's actually in the array, the statues array. And if it's not, then we'll increment count. So we could do something like if, okay, actually this is an interesting situation. Okay, this isn't something we've really talked about yet. So maybe we'll talk about this. We'll talk about how to check if an element is in an array, and then we'll return to this afterwards. So just to simplify things, let's just get this off the page for now, and we'll go back up, and we'll just say something like var r, just doing a sample array here, and it's going to be something like -8, 12, 9, 0, 15. Okay, great. So there's our array, and we're going to use a built-in for arrays here. It's going to be indexOf. So basically, index of, the way it works is, let's say we wanted to know if, well, first of all, let's say we wanted to know where 15 was located in the array. So we'd say array.index of 15. Where is 15 in the array? It's at index 4. Okay, it's 0, 1, 2, 3, 4. It's at the spot with index 4. Great. We could do 9 or something like that. It should be 2, 0, 1, 2. That should be the answer we get for the next one, and we do. So there's 2. Okay, great. So that's nice. But let's say now we want to know, well, where's 11 in this array? Now, just by inspection, just by looking at it, it looks like 11 is not in the array. So let's try. And it's going to tell us -1. So that might seem like a strange answer. We don't necessarily think of -1 as being kind of like a falsy value. We might expect something like maybe 0 would make more sense. Well, the reason it can't be 0 is because there's already something in the array that has an index of 0. So 0, yeah, it's typically used as kind of a false value, but we can't use that here. We have to use something different. So basically, whether it's 11, whether it's 8, as long as it's something that's not in the array, it's just going to give us -1 as a response. So basically, that's indexOf's way of saying, actually, that thing's not in the array. Okay, so that's basically a way that we can check. So we could say something like, if r.indexOf 5 is greater than -1, then console.log, it's in the array. And else, we'll do a console.log which says it's not in the array. All right, so basically the idea is that if this number is in the array, we're just doing a quick little console log here. We're saying it's in the array. So it's not in the array. 5 is not in the array, and that's true. 5 was not in this array. Okay, we could make it something. Well, let's just make sure it actually does work. So we'll run 12, and it's in the array. Okay, great. So basically, this is a good conventional way of checking to see if something's in an array. We'll check if the index of that element is greater than -1. But of course, we always want to be sort of thinking semantically. We always want our code to, as much as possible, speak for itself. And obviously we can use comments and stuff like that, but if we can use syntax that just isn't too far from the way we would actually talk about it, then that's probably better. So normally, if we wanted to check if something was in an array, we'd say something like, is it in the array? Is it an element of the array? Does the array include that element? That actually happens to be the syntax. So we're going to do r.includes, and we'll just use 0 as an example here. Is it in the array? It's in the array. We can see that right down here. Okay, great. And it is in the array, so that's good. And here, let's just do 1,000, see if that's in the array. It's not in the array. So this is working just as well as the indexOf thing that we had before, but it just makes a little more sense, a little closer to how we actually talk about this stuff. People probably wouldn't be like, oh, hey, is the index of that element in the array greater than -1? We'd be like, what are you talking about? Does it include that element? That's a clearer way of saying that. So usually this is the syntax that I use. I believe it's a more modern syntax, and I'm not sure, to be honest, how it compares in terms of computation time or anything like that, or if there's some limitations where we shouldn't use this. So if anyone knows, definitely, I'd be happy to hear about it. But this is basically what I'm going to be using for the most part, just because it speaks for itself. Okay, so instead of R here, we're talking about statues, and instead of 12 or 0 or whatever I was using, we're talking about this number n. So we're going to do something like this. If statues.includes n, well, if it includes it, then we're actually going to do nothing. And if it doesn't include it, then we're going to increment count. We're going to increment count. Okay, great. I mean, we could do other stuff here. Like, we could also just keep an array of the ones that it is missing. We could do like something like var missing is this empty array, and then down here we could do missing.push n. And at the end, what are we doing? We're returning count. Let's say return missing, and we'll see how that works. We should expect, yeah, 4, 5, and 7 for this one. We're getting 1 and 2 for this one. And notice there are 2 elements here. 2 is the answer. This one has no elements. That's the answer. So if we wanted an answer to this thing, we could just do something like this. I mean, right off the bat, it looks like our algorithm is working pretty good, so we could just do something like missing dot length. We've talked about dot length before. It just tells you how many elements are in an array. So with this, well, hey, that works. That's good. But we're not going to do it that way. This whole missing thing, I mean, it's overkill. It's not asking us which elements are missing. It's just asking us how many are missing. So if it was asking which ones, then yeah, for sure, we'd use this missing thing. But no sense in putting a whole array in memory, no sense in having to do a push operation or having to even measure the length of an array if we don't have to. If we can just do it all with this count variable, that's probably better. That's probably going to be a little faster. So that's good. Okay, so we're looking at a working algorithm here. That's not bad. But maybe we can clean it up a little bit. So first of all, the first thing that's bothering me a little bit about this is this thing right here, the if statues.includes and do nothing. No sense in checking this if it's just going to be a do nothing. So instead of doing this, we're going to flip it around. Instead of saying, well, if statues includes n, we're going to say if statues does not include n. Now there isn't a built-in for like not includes or anything like that, but that's fine because anytime we have a Boolean and anytime we have a logical statement, a true or false value, we can always negate it. We can always do the opposite by putting this not symbol at the front, and it's an exclamation point. So just put that in front of any Boolean, and it'll switch the value from true to false or false to true. So now, well, we don't need this middle part anymore. This should be enough because it's basically saying if not statues includes n, then increment the count. So let's run that. And there we go. Okay, it's still working, so that's nice. Now I mentioned this before, but if we've got an if statement that's just one line, we don't need the braces. We can just put it right there, and that should still work, and it takes up less space that way. Some people don't like to write it that way, so I mean that's fine. I don't know if there's an actual difference in terms of the computation time or anything like that. I mean, you save a bit of bytes this way, but if it means that you're losing clarity, maybe it's not worth it. So main thing, make sure it's clear to the reader. Okay, so we're looping from min to max. We're checking if it's in the array. Well, check if the element is not in the array, actually. And if not, increment count. Okay, there we go. That's a little more accurate. All right. Next thing I want to do before we submit or anything like that is I want to talk about this. Because we're doing this spread operator, and I mean, this looks nice. It's pretty simple. We don't have to think too much about it. But is it the best way to do it? It's not bad, but I think we could do better, because if you think about it with this spread operator, we've got to go through the whole array once to find the minimum, and then we need to go through the whole array again to find the maximum. So maybe there's a better way we could do it. So we could do something like for var I is assigned the value 0, I is less than statues.length, I plus plus. So again, very conventional way of doing a loop that's going to run through every element in the statues array. And then we could just do something like var element is assigned the value of statues at I. We could have called it statue or something like that. I don't usually like to have a plural and a singular form of the same word as variables because it just makes the autocomplete a little more complicated. So var element is assigned the value of statues at I. That's just our current element. And I'm using a variable there so that we don't have to check it more than once. So, okay, that's our element. And we could just say something like, if element is less than min, then min is assigned the value of element. And if element is greater than max, then max is assigned the value of element. All right, now the reason I want to do it this way is because this is only going through the array one time, as opposed to this, which loops through it twice, essentially. Okay, so the problem here is that we've got to change these. We don't know the initial values of min and max now, so we could do something like maybe min will start as something like, well, hey, let's just make them both 0, and then we'll see how that goes. So is that going to work? We'll pass all the tests the way it did before. No, that didn't work. Okay, so I wonder why that didn't work. Well, it's telling us 5 instead of 3 now. It's telling us we're missing 5 things. And if you think about it, the reason is because there's nothing in this array that's less than 0. So by saying that min is 0 right off the bat, it's never going to find something that's less than that. So it's actually using 0 to 8 instead of 2 to 8. So that's why it's saying 5, because it's missing 0 and it's missing 1. Okay, so 0 wasn't a good starting value here. We should make it something that's like really, really big. So now maybe we'll check our guarantee constraints. Okay, we're only going to be looking at values between 0 and 20 here. So we could say minimum is going to be 20, maximum is going to be 0. Since we're guaranteed that the numbers aren't going to be less than 0 or greater than 20, this should work just fine. Okay, nice. But if we're worried about this, if we're thinking like, well, what if they switch these up? What if we wanted a more generalized version that's going to work without these constraints? Well, we could do something like make min something really, really big. We could make it like 1 billion. And then we could make max something equivalently large, but in the opposite direction. So instead of 1 billion, we'll make it negative 1 billion. And we talked about this more efficient syntax for that, 1e9 versus negative 1e9. So we could do that, and that'll work. Or we could also make these undefined to begin with and put another if statement in here. I think we looked at that in the previous video. But the main thing is, for something like this, the way I usually like to do it is just take the initial value. So start where the array starts. Whatever this number is, at least it's something in the array. So maybe we're starting in the middle. Maybe we happen to be starting at the min or the max. I'm not sure, but the main thing is we're starting at the beginning. And the other nice thing about doing it this way is we don't actually have to check the 0th element because we've already gone through that. So we could just do something like this, and it should still work the same way. There are other ways to do this. Like I'm pretty sure we can get away with this kind of syntax: min equals max equals statues at 0. But I don't know if I like to do it that way, mainly because if you look at max, notice how it's green there? Like it doesn't have the var right in front of it. So I think there's an issue with that. If you don't put the keyword var in JavaScript, then it means that's going to be a global variable. So that means it's going to be accessible outside of the scope of this function, which is not what we want. We want it to be strictly within the scope of this function. In fact, we kind of talked about these other keywords like let and const before, and we could use those as well. Like for example, over here, like this I variable, we don't really need to use I outside of this array at all. So like here, just to show you, we could return an I mean, it's just a var, so I made it up to 4. It makes sense. There were 4 elements, so 4 is statues.length. That's where the loop stops, so it makes sense that it'd make it to 4. Now, if we were to use let instead, then that means we can't get I. We don't know what I is, because I only exists within the scope of this block right here. So that's the advantage of using let. It's a little more secure. I mean, if we don't need to access I outside of the loop, then no sense in making it accessible outside of the loop. So we're going to get more in the habit of using these kind of lets and const and stuff like that. If we were to use const here, it's very similar. It's block scoped as well, except the difference is that you can't reassign a const. So in this case, it's going to have an error because it's saying, hey, what are you doing? You can't reassign that. That's a constant. As a const stands for, by the way. Okay, so there we go. We've got let, and we can make these lets as well. Might as well go ahead and do that, I guess. Let, and let. It's kind of like a let statement in math, like if you're doing a word problem or something like that. Might as well get a let on this one too, right? We're not trying to access the variable n outside of this. Okay, so nice. This is good. So we're going through the array one time here. We are getting the maximum minimum elements that way, and it's working. I mean, it's giving us what we're looking for here. It's passing all the tests. So let's see. Should we submit this? Is there anything missing? I think we're ready to submit it, so let's give this a quick submission. We'll see how it goes. Oh, yeah, there we go. Okay, so that's nice. We solved it, we passed all the tests, and look at that, we're 10% of the way. That's pretty not bad. Okay, so I'm going to close that, and well, let's see. I mean, it's nice that it passed all the tests. It's nice that that we collected the points and experience and all that stuff, but could we make it better? Well, yeah, we can make it better. So first, I want to make it just a little bit better, and then after that, we'll make it a lot better. So going back to the drawing board, so to speak here, there's another way that we could do this. You'll notice the way I first wrote these down, I kind of wrote the existing elements that we have in order. So instead of 6, 2, 3, 8, I wrote them down as 2, 3, 6, 8. So maybe that's something we can implement into our algorithm. We could make it start by sorting the elements in the array. And then in terms of how many there are going to be missing, well, there's kind of another way we could think about that. So we could say, once we go from 2 to 3, what's the difference between 2 and 3? Well, the difference is 1, so there isn't anything in between those, so we don't need to add anything to count. Okay, and then we go from 3 to 6, because we're only looking at the elements that are actually in the array now. And we say, what's the difference between 6 and 3? Well, the difference is 3. So we'd have to go up 1, 2, 3 to get from 3 to 6. So that means that there are 2 elements that are missing in between. So basically it's the difference between these minus 1. So diff minus 1, I'll just write that out. And if you think about it, that's consistent with what we had over here as well, because when we did 3 minus 2, well, the difference was 1, and then when we subtract 1 from that, that's going to give us a big old 0. So it makes sense. We don't need to add anything for that one. Difference here is 2. 2 minus 1 is 1. And yes, we did have to add 1 element in here, just like we had to add 2 in this case. Okay, so maybe we can make it something like that. So it's going to start by sorting the array, and then after it sorts them, it's going to iterate through, and it's just going to be looking at the differences between each of the elements. Okay, so let's do what we normally do, I guess. We'll just sort of comment this part out, and we'll start fresh. We'll see which one's better after that. So, oh, whoops. So this way it's going to keep this as part of the solution in case anyone wants to take a look at it later. Okay, but actually, maybe I'll just reuse this bit right here because that wasn't too bad. I mean, we do want to know the count. We ultimately want to return the count at the end. It's just how we're going to get the count that's actually going to differ. This stuff is all going to be the same though. So how are we going to get the count? Well, we're going to sort the array. Then we're going to iterate through the array and add difference minus 1 between consecutive elements to count. All right, so one thing at a time here, we'll sort the array. I believe we talked about sort before. Actually, yeah, we definitely did, because that was actually a way that we found the minimum. That was one of the methods I forgot to mention, actually. So we should talk about sort. Basically, the way we're going to do it is like this. We'll say dot sort. And if you remember, if we don't put in an argument here, if we just make it dot sort regular like this, then it's not really going to work because it's going to sort them lexicographically. So it's going to sort them as though they were like strings, like words, you know? So we're not going to use this. Instead, we're going to put in our own function here, and it's just going to be a minus b. Because the way sort works is when it's comparing 2 elements, it just checks if, basically, if you return a positive. I think it's that if you return a positive, it won't switch them. If you return a negative, it will switch them. It's either that or the opposite of that. But anyway, the point is, it's looking for a positive or negative. It doesn't care like how positive or how negative it is. It's just, is it positive or negative? So before we go any further, let's return statues. And let's be sure to do that in such a way that we spell return properly, because otherwise it wouldn't work. Okay, so great, 2, 3, 6, 8. That's what we're looking for. Is this what we're looking for? It is. Is this what we're looking for? Sure is. Okay, great. This is looking good so far. So this is consistently sorting our array. Now, what I was saying before basically is if you want the minimum, we could just do something like that. You know, just take the 0th element of the sorted array, and that will give you the minimum element. But that's not what we're trying to do anymore. So we just want to sort the array. Actually, now that I think about it, maybe that is a better way to do it, because if we're sorting the array anyway, yeah, okay, so actually we won't recycle this stuff over here. We're just going to, here, let's do it like this. So we're sorting the array. I don't think we need to return the sorted array anymore, so I'll get rid of that. And we're going to say let min be assigned the value of statues at 0, and let max be assigned the value statues at statues.length minus 1. That's always just going to give us the last element in the array, because keep in mind statues.length would be too much. You know, if there are 4 elements in the array, then there's not going to be an element with index 4. There would just be 0, 1, 2, and 3. Okay, so there's min, there's max. We've got both of them, and there's too much space here. Let's clean this up a little bit. Okay, so we sort the array. We identify the max and min elements, and you know, this is looking pretty good. It's looking pretty efficient at this point. So we got our min and our max. And one last thing I just want to mention before we move on is the fact that, notice I didn't have to say, like, you know, let sorted be assigned the value of statues.sort, etc. This sorts them. So this actually does modify the array here. So that's worth knowing. It's I believe we looked at splice before was another one that actually modified it, as opposed to something like a slice that doesn't. Anyway, the point is, so sort will modify the array. So that's good to know. All right, so we've got min, we've got max, and we want to iterate through the array, add the difference minus 1 between consecutive elements to count. Okay, so we'll do a for loop. Our I is 0, I is less than statues.length, and then I plus plus. And we basically want to say, let's say var difference is assigned the value of statues at I minus statues, not states, statues at I minus 1. So basically the current minus the previous, that's the difference between them. And we know that that's always going to be a positive number because the array is sorted. It's going up. Okay, or at least it's going to be a non-negative number. And then we'll say count. Well, we could say something like count is assigned the value of count plus difference minus 1. Or another way we could do that, since we're adding this stuff over here to what this variable already was, we don't actually need to repeat ourselves so much. We could just say count plus equals difference minus 1. Okay, so now let's run this and we'll see if it works. And it doesn't. Okay, why is this not working? So it says we're getting a null here. Well, that seems kind of strange for it to be null, because we're saying return count, and count clearly has a value here. I mean, what if we were to return count at this point? Will that still give us null? Is it somehow losing the 0 value? No, that's still intact, so it's not that that's causing a problem. It must be something that happens between that line I just wrote and the end down here. So maybe it's not getting to this because it's having some kind of error in this loop. So why would I have an error in the loop? Well, let's think about it. When we think about what the loop is doing, it's basically saying the difference is the current element minus the value of the previous element. Problem is we're starting it at 1. So if, we're starting at 0, which is the problem, because that means if I is 0, then 0 minus 1 is negative 1. There's no negative 1th element in an array. I mean, just like when we were doing the index of, you know, it would return negative 1 if something was not in the array. So we're not going to start at 0. We are going to start it at 1, just so that we're actually looking at the differences. So again, going back here, notice there were only 3 comparisons we had to make, even though there were 4 elements in the array. So really, this should fire 3 times, basically 1 less than the length of the array. So that's the way we're going to do it. We could also, you know, start it at 0 and then make it go to statues down like minus 1 and then do I plus 1 minus statues down. But, I mean, it's up to you, whichever you prefer. Okay, great! That one worked. And that was a little more efficient. So, okay, if you're looking at this and you're thinking, well, it doesn't seem all that different from the previous one. You know, it seems like it's about just as complicated. You're still iterating through an array. What difference does it make? You know, you're looking at, you're looping 3 times instead of looping, what, 7 times? So is it better? Well, I would actually say In this case, it doesn't matter that much because, again, the constraints are very not bad. You know, they could be a lot more outrageous than this. These are pretty confined to small numbers. So if these were much larger numbers, in particular, if the values in the array themselves were much larger, that's where this algorithm starts to make a big difference. Because, I mean, even if the array is only 10 elements long, it matters how big the elements inside are. And the reason I say that is because this one is basically saying, let's start at the min, let's go all the way to the max. So even if there are only 10 elements in the original array, let's say the values, instead of going from 0 to 20, let's say they could go from -1 billion to +1 billion. Well, if you had an array that had -1 billion and +1 billion in it, then this loop is going to go forever. This is going to cover like 2 billion elements, even though there are only 10 elements in the array. That's absurd when you compare it to this one, which would only go 9 times if there are 10 elements in the array, regardless of what those elements are, because it's basically just using math here to get the difference -1. We don't have to iterate through if we can just do it mathematically. So that's a little more direct. That's probably better. Which leads us to wonder, could it get better than that? I mean, we're sort of embracing this idea of using a mathematical solution, using a more sort of constant time solution. So maybe we can take advantage of that, and we can find a way to use even more sort of math tricks here. So I am gonna grab this stuff again just to sort of get the max and min elements, and I'm gonna pop that up top here. This is gonna be, I think this will be our final attempt at this. So we'll have 3 versions in the end here, and it's not gonna be that much different. I mean, we're still gonna keep all this stuff to find the min and the max, but the way we're gonna do it from there, well, it's gonna be sort of interesting. So if we look at this, we had the min on the left here, which was 2. We had the max, which was 8. And basically, if we think about, well, how many elements are there here? Well, 1, 2, 3, 4, 5, 6, 7. Okay, so basically we could get that by doing the max minus the min. So 8 minus 2 would give us 6. And then plus 1, because we also want to include the 2. We also want to include the 8. So basically, I'll switch colors for this. So I'll say total needed, let's say, right? Because that's basically all the statues that that RadioOrg wants to have in its collection. So total needed is going to be equal to max minus min plus 1. Max minus min plus 1. Again, we're adding the 1 because otherwise we're just sort of looking at the difference between them, whereas we want to include the endpoints. We want to include the 2 and include the 8. Okay, so total needed is max minus min plus 1. So if that's how many we need, then, well, how many do we have to begin with? So total have, I guess I'll say. Well, in this case, we have 4. And it wasn't very difficult to determine that. All I had to do was look at the array and look at how many elements there are. So basically, this is just going to be statues. That's the name of our array. So statues dot length. Okay, there we go. That's going to look a lot nicer when I actually type it out. So let's do that. So total needed, and then total have. There's probably a more clear way we could write that, but oh well. All right, so total needed is going to be, I guess I'll say var needed is assigned the value of max minus min plus 1. Very nice. Okay, and then total have, var have is statues.length. That's it. It's just statues.length. Nothing more we need to do to that. So total needed, max minus min plus 1, total have, statues.length. Now the question is, how many do we need to add? Well, in this case, it was 3, and that was just the total needed, which was 7, minus the total have, which was 4. 7 minus 4, 3. So that's it. So basically, if we want the total lacking, well, it's just going to be how many do we need minus how many do we have. So it's just going to be return needed minus have. And we'll run that. Excellent. Okay, that feels good. It feels especially good actually because with this algorithm, number one, I think it's pretty clear. It's well commented. We've got nice variable names and stuff like that. The main thing is, aside from just going through the array once to pick out the minimum and maximum elements, we don't need to do any loops aside from that. So this is going to be the most efficient one. I mean, basically, as soon as it's done this stuff here, it basically just gets the final answer with just a couple math steps. I mean, the computation time of this stuff down here, it's going to be pretty negligible. So it's basically as direct as we can make it. Compare that to something like our original, and basically this is the stuff that we kept from that. And then after that, we went through this loop, which, as we determined, it could be a pretty long loop depending on the size of the elements. Now, we improved that with our second algorithm, but this one also has a loop. And this one could also be a very long loop if we had a whole bunch of elements in the array. If the length of the array was a lot longer, this one could really start to expand. This one, it's not going to be as bad. I mean, really the only thing we need to worry about is this part, I guess, if there was a whole bunch of elements. But there's really, I don't think there's a better way we could actually get the minimum and maximum elements. So this is basically as good as it can get. And actually, we're not using count, so we can fit this all together here. Yeah, perfect. Okay, so that's nice. Let's submit that as sort of like our final answers. Then anyone who wants to check this out can just click on the solution over here, and it's going to have 3 different strategies here, each with their own disadvantages, I guess. But this one has the fewest disadvantages. Okay, great. So